As many of you know from my channel, I put a lot of time, energy, and money into restoring my 2000 Triton TR21. Inevitably, things change, and this is my Triton pulling away after being sold. The Triton was originally equipped with 5-inch electronics at the bow and at the console. In today's technological world, electronics require better wiring and more power. Today's video will explore many of the upgrades that I made to my Triton boat. The Triton wiring upgrade video will offer many helpful suggestions and will be considered part 1 of a 2-part series. Some of you may have noticed that the last 2 pictures were not from my Triton, but actually from this Ranger Z520C. This new-to-me Ranger will be the beneficiary of many of the improvements in wiring upgrades that I have learned through my Triton, and I am excited to share those with you in the next part 2 of the series. I had, as you can see, 531 series batteries powering my boat and electronics. For my cranking and electronics batteries, I purchased 2 batteries at the same time, as it's not a good idea to mix old and new batteries when hooking up in parallel. Whenever you do an upgrade to a wiring system, it is super important to use marine grade tinned copper wire to run directly to fuse panels if you choose to go that route, or if you want to wire the electronics directly to the batteries. Standard copper wire is a cheaper alternative, but I would rather do the job right the first time and make that job last. The marine grade tin copper has a white protective sheath around it, and you can see over here that it has the wiring here, and for the Triton I used 10 gauge wiring to the fuse panels. There you can see how the tinned copper is a nice silver color as it's coated to prevent corrosion. Nobody ever complains about having too much battery power, so I highly recommend you using the largest size battery that will fit in the available space. Group 24, 27, sometimes 29, and 31 are the most common size batteries. 31s maximize battery life. With 531 series batteries, I had to be creative about where to put my chargers. The only real option I had was underneath the lid. Minn Kota does not recommend putting chargers above the batteries, but since I have a garage, I was able to keep the lid open and charge the batteries so that the chargers were not directly above the batteries while charging. I also did my best to ensure that the chargers were not directly above the batteries. For example, one was above the oil jug and the other was in the space between the batteries for the trolling motors. The Minn Kota 330 precision charger was used to charge the 36-volt trolling motor system. The 220 PC was used for the cranking and electronics batteries. Minn Kota power port outlets in conjunction with onboard chargers are a super convenient way to get your batteries charged quickly and efficiently by simply plugging in 2 extension cords. It works great. It's a great idea to have master switches, one to turn off the electronics and one to turn off everything else. I also added in a couple of terminal posts with the red positive on the top and the black negative underneath it. This was designed to help eliminate the abundance of wires directly connected to the terminals of the battery, and it certainly cleaned up the install. With the optional terminal connectors, you can see that the terminals on the battery have been minimized. This fuse panel worked for a lot of years, but definitely time for an upgrade. The old fuse panel was located on the side wall underneath the console. The new fuse panel has a piece of blue conduit which has white marine wire coming out of it, and you can see the green arrow pointing to the nice thick 10 gauge red wire, and here you can see hooked up and in operation. Labels and indicator lights help you troubleshoot problems much faster. The red light will flash if the fuse has blown. Here's a close-up of the console fuse panel, and I've got 10 gauge wiring. I was going to go with 8, but it was pretty darn expensive, so I opted for 10. And again, I have it secured with a cable tie. And coming back, I have all the Ethernet cables labeled and going into the hubs, and I have the jumper for the 2 hubs going from 5 to 1. Today's terminal connectors are much better. They are tinned copper, and they also have an adhesive in there when you heat it up afterwards, so you don't have to solder. And having a wide variety is a big help as you are going through. Here's a kit that I used to help with my wiring. When you heat these connectors up, they also have the shrink wrap already on them, so it is a nice, tight, secure connection. For the jumper cables, I used this kit, and you can see that it is tinned copper eyelets, and there's a good selection of terminals here for 6/8 gauge wiring, predominantly for the jumpers. Since these terminal connectors do not have adhesive or shrink wrap, it is a good idea to add a little bit of solder and shrink wrap when installing. Adding dielectric grease to your terminals is an efficient way of blocking moisture from the terminals, helping to prevent corrosion. This grease is helpful with tinned wire, but is especially important for corrosion resistance in standard wire. So here is the back of the trolling motor plug, and this is where I originally got the idea of taking the pipe insulation. Since the trolling motor wires are your #1 source of interference, I wanted to get them out of the way. And you can see that I do have a fuse panel in the bow installed there, and this is going to keep the trolling motor wire interference as far away from possible as it can be. And this is why I am separating the trolling motor wires from the power wires. And then over here I have a notched area that any transducer cords for down imaging in my Mega down imaging Ultrex. And then over here coming further, I am going to run my Ethernet cables, trying to keep them apart as best as I possibly can. Again, just to clarify what I mean by being apart, my Ethernet cables are separated from the transducer cables, which are going to go in that notch, separated from my power cables, and separated from the trolling motor battery wiring. And once again, the most important basic principle of wiring boat electronics is keep your trolling motor wires on the opposite side of the boat from your power wires. And my power wires are all running up the starboard side. The beauty of a fuse panel is it is going to help me troubleshoot very quickly where there's a problem. If I have a fuse pop, one of those lights will come on and I will know right away. I even went as far as putting some pipe insulation on my plug cord because it was close to my power cords. Always try to make your install clean, neat, and organized. I put a cable tie around the fuse panel just so that the protective cover would not come off when it gets rough. Here is the bow panel and just a summary of what I've tried to do. And there are my Ethernet cables. There is the MKR MI1 for the built-in Mega down imaging on my Ultrex. There is the Mega 360 cables, and you can see they are separate from the fuse panel. And my trolling motor wires, which I mentioned earlier, are covered in the pipe insulation. Everything is separated as much as possible. And that was one of the main reasons I went to the fuse panel, because it just allowed me to neatly separate things in a more efficient manner. I can always go back to wiring direct if I find the fuse panel is not working, but it just made more sense to me to go with the fuse panel as opposed to not go with the fuse panel in the bow. And that's what I did. I really wish I had taken a before and after photo of the bow compartment area, as it was just stuffed with wires, and this is such a vast improvement. You have no idea without the before and after picture. My fuse panel is mounted on an aluminum plate made at Triton, thanks to Jeff Tunks. And you can see I put some grommets in there, and you get a little better look at what I did there. Both fuse panels are wired directly to the batteries with 10 gauge marine tin wire. Securing and labeling, and you can see how I've secured with little cable wrap, I'm not sure exactly what you call them, the electrical things to lock in the cables. That's going to save things from bouncing around. And of course, adding labels is going to certainly make life easier moving forward. So that is basically a wrap on the bow. I used a rotary tool to create a notch in the fiberglass so that the cables will sit in, and I filed off the edges to make sure that there were no sharp edges. Those of you who watched my Mega Live Ice Crate Shuttle video, this is where I put the 30 amp hour Amped Outdoors lithium battery, and I put it on a switch, as you can tell over here, and I will just open it up for you. And I just left it in the enclosed insulated ice fishing case that I made just to give it added protection, and that will be used for the Mega Live as a clean power source. The battery and switch are located in the starboard side rod locker. This Amped Outdoors 30 amp hour lithium battery has been featured in many of my videos. It's a workhorse, and I have used this battery to run a Helix 12 and my Mega Live all day. A huge advantage of a lithium battery is that it runs at full charge and doesn't taper off like conventional batteries. This Amped Outdoors battery has been awesome. Here's the aluminum tray and strapping that is securing the lithium, and it is bolted to the console, and that tray is not going anywhere. I also have an aluminum plate here that is made for this switch. Lithium batteries are very light and last much longer than conventional batteries. The Humminbird Mega Live does not require an independent battery source such as this 30 amp hour Amped Outdoors battery. When I bought the battery for the Ice Shuttle, I bought it keeping in mind that I might possibly want to use it on the boat as well for an independent power source. With my cranking and electronics batteries hooked up in parallel, it was easier to opt for an independent clean power source. All of the Ethernet cables are secured at the top of the rod locker, and I just used small screw eyes and cable ties to secure the Ethernet cables down, and they are not hanging down in the rod locker anywhere to interfere with the rods, which is very helpful. The Mega Live power cord is secured to the wall of the rod locker, and it is coming into the lithium battery. Well, this may not mean much to a lot of you, but to me, having no wires inside of the rod locker to wrap around my tips is a huge step forward and a big accomplishment in this project. By completing this wiring upgrade project, I was able to utilize 4 Helix 12s with Mega 360 and Mega Live. On and off switches are an important part of the upgrade process, and I highly recommend that you put them in. My Humminbird manual instructions clearly indicated where you needed the on and off switches. Every time you complete a project, you learn a lot in the process. Part of the learning process is learning what you like and what you don't like, and what you would like to improve upon the next time you complete a project. Rewiring the Triton was an important learning curve, and I am super excited to share with you what I have done to the Ranger in part 2 of this video series. Hopefully you found some helpful hints in this video, and as always, a like, share, subscribe is always very much appreciated. Take care, and bye for now.